Hello everyone and welcome to my YouTube channel. Today we are going to do the lab of site-to-site GRE tunnel, and over the GRE tunnel we are going to run the routing protocol. We will run OSPF routing protocol. We will first form a GRE tunnel between these two FortiGate routers, firewalls, sorry. And over that GRE tunnel we will use the OSPF routing protocol to share the LAN routes with each other. Okay. So what does basically GRE tunnel does? So in GRE tunnel, we basically define a source and a destination. Okay. So whenever our traffic will come from the LAN, the GRE tunnel will encapsulate that source IP, the actual source IP and the actual destination IP within its GRE packet, and it will use the GRE source, which will be this one, the ISP facing source, the destination. So whenever if ISP does a packet capture, it will see that the sources of the, the ISP router and destination is of the next the public IP destination. It will not actually see the what we can say the actual LAN IPs. Okay. So it is basically used for hiding our LAN IPs with the public world. So let's get started. I will from start to end I will show you the lab. So this is my internet router. So we are done with the internet router configuration. Now we will move towards the FortiGate firewall. You can give any password. I am giving 123. I will keep the mode as static. Set IP 192.168.0.114/24. Okay. Set allow access HTTP HTTP. Okay. That's a mistake. So this is the GUI of the FortiGate firewall. I don't want any specific question. So over here, and I'll now configure the basically the LAN and the WAN interfaces. And after that, I will give a static route, and after that, I will give the GRE tunnel configuration. Okay, so let's get started. So first of all, we will go into the network interfaces. Port 3. So port 3 is our LAN facing interface. This one, /24. And I will configure it as a DHCP server so that automatically these users will get an IP from here. Similarly, I will go to port 2. This is our WAN. 30.1.1.2/24. Okay, so interface configuration is done. I will give a static route. 30.1.1.1. Click on OK. Similarly, we will do the configuration of the second FortiGate firewall, which is this one. Okay. Similarly, I will give a static route. Okay. And I'll click on OK. So this is the basic configuration which is needed. Now, what I will do, I will do the GRE tunnel configuration, for which we have to go into the GUI, not in the GUI, in the CLI. So let's get started. System, GRE tunnel, edit, GRE, set local gateway. So what is our local gateway? So local gateway is 30.1.1.2. Set remote gateway, which is this one, which is 40.1.1.2. And I will say this set interface. Interface will be this one, the WAN facing interface. Set interface port 2. So what we are doing basically over here is, okay, we are defining our local gateway and the remote gateway. We are going to form a side-to-side GRE tunnel between these two VPN devices, FortiGate devices. And if they want to exit the traffic, so it should go via port 2, which is the WAN facing interface. Okay, I think this much is enough. Just click on it and I'll just go over here. See, GRE tunnel is built. What I will do, I will configure an IP address over here because our GRE tunnel is there, but how we are going to share these routes between these two sides. So there should be a routing protocol. For building a routing protocol, we should configure an IP address for the GRE tunnel so that because GRE tunnel supports multicasting, okay, you can configure any kind of routing protocol like EIGRP, OSPF, and RIP. So the so for forming the route, so for neighborship to come up, at least there should be an IP address so that they can form the routing protocol multicasting neighborship. Okay, so what IP I will give is, say for example, 11.1.1.1. This is my source IP, 11.1.1.2/24. STD place SSH page. Okay, and I'll click on OK. Now, if I check over here, and this click on show, IP address is not reflecting over here. Not sure why. I think it will reflect as well. But never mind. I'll just go behind and I'll complete the next configuration, which will be the firewall policies. I'll just click number one. So our incoming interface will be LAN and the outgoing interface will be GRE. I'll keep the source as all, destination also as all, service will be also all. Here is the important part. We don't require netting over here. Okay, we don't want our private IP address to be translated into the GRE tunnel IP addresses because it is already going to do the encapsulation. Click on OK. Similarly, I will create the second policy, which will be GRE to LAN all, all. Service will be also all. Obviously, we don't need netting over here. Similar. Now, what we will do, we will configure the firewall again over here. You have to go into the CLI. The local gateway will be over here 40.1.1. Interface 4. Just click on refresh. You guys can see. Now we have to exactly do the opposite over here in terms of IP addresses. So this will be the IP over here, and okay. And I think we are done with the GRE tunnel configuration. Okay, so Now we will check the IP reachability. See, uh, we are having a default route. I'll just use 3.1.1.2 and see it's reachable. Okay. Similarly, I'll check from over here. Security pin. Now, how about the LAN traffic? Because this firewall doesn't know how to reach 20. Okay, you guys can see there is no route for 20. So now you can do one thing. Either you can define a static routing. You can just go over here. You can just define the destination 24 and define the GRE tunnel. Okay. Or else, since we have given an IP address over here, if you check on the interfaces, we can run a routing protocol in these two GRE tunnels for sharing the internal subnets, our private IP addresses, which is more feasible according to me. Okay. But for that, we will first check if we are able to use the GRE tunnels or not. We are able to ping the local IP. Similarly, I will see that is also reachable. Okay. The side B FortiGate GRE tunnel is also working. We'll do one thing now. We will configure routing protocol with our LAN prefixes with within the OSPF routing protocol. OSPF, give the router ID. I will give the router ID as this one 30.1.1.2. I will create an area. Area, I think I will keep it them as area 0. Okay, those who are from Cisco background, here 0.0.0.0 means area 0. Okay, you don't want any kind of authentication or any kind of hashing algorithm. Sorry, any kind of authentication over here. I'll click on OK. And which network you want to advertise? So we will advertise the LAN network. Area will be 0 only. Within area 0, we want to advertise the LAN /24. Okay. And on which interface you want to run the routing, basic routing. Give them as GRE. Interface will be also GRE. Learn that. That one. That one. Okay. And we don't want the network to be broadcast. Okay. We will keep them as point to point. And I'll just I don't want this another things over here. Passive interface and everything. And I click on OK. Hello interval you can define if you want. By default it is 0 and 0. Click on OK. And these are other things guys which comes into OSPF, but this lab is not about OSPF, it is about GRE tunneling. And I'll apply and you can just re-verify it again. Okay. And view routing. Similarly, I will go over here and I'll again go into network. OSPF. Here I will keep the IPS 40.1.1.2, which is the WAN IP. This one. Area 0. Network will be also 20 dot. And create interface. for the neighborship. The neighborship will come up now. It will take some time. I think the firewall policies I have not created. Meanwhile, I will create the firewall policies. LAN to GRE. Similarly, keep them all. Service will be also on. My interface will be the GRE. Let's check what is the status over here. Okay, let's troubleshoot this now. 30.100.1.2 is this one. I think I have to define the hello and dead interval over here. It should be hello interval is by default 10, dead interval is 40. Okay. I'm not sure why it's not working. Let's troubleshoot, guys, how it will work. Just today, today only I did this lab and it was working. Same. Interface, I think these should match. Hello, same hello. Interface should be dead. This is okay. It's not taking the. I think it's not taking the. What I can say. Okay. Everything is fine. Not sure why it's not working. There is something over here. Let me just check. Default it is in areas here only. think I have to advertise the GRE tunnel IPs. Okay, let's wait for it. Area 0 only 11.1.1.0/24, and it will work because the neighborship is going to form between them over the GRE IPs. Now let's go. And, not over here, I think over here. Let's check now. It's working or not. No, it's not coming up. Yeah, it's coming up, guys. See, because that network was not advertised, so hello intervals were not going on the GRE tunnels. So it's in full state now. It is showing the remote GRE public the GRE IP address. See. Now, if you can check in the routing table, I'm grateful that this issue came. Okay, so what was happening basically, guys? I was not configuring the GRE IP address over here. This IP address. I was just like sharing the prefixes 10.1. But I was not configuring my GRE tunnel for participating in the OSPF neighborship. So that's why it was not working. So you can just check now over the static and dynamic. You can see OSPF option is also there now. And if you click on OSPF, see 20 dot network is getting learned by this public IP, this GRE tunnel IP. Okay, I'll just check. See, it's up. Okay, get router info, voice cliff. I'm able to learn this private IP from the 11.1.1.2. Okay, and let's see. This IP is getting learned by OSPF. AD value is 110 by default. Similarly, if I go over here, here also you can see GRE. So let's do a side-to-side ping. So they will obtain a DHCP IP address from over here. Now I will ping the 20.1. See, it's going. Now I will ping the we will get the forward traffic or local traffic. It's not showing. I think we have to go into the firewall and check. System session list. See, here you are seeing that the session is found between the 10.1.1.1 and 20.1.1.1. Okay. speed of checks the public IP address. It will see the tunnel IP. So let me I will stop this ping. There is no visibility of the what I can say the GRE tunnel IP as well as our private IP address. You can see the communication is between the 30.1.1. Just take this example. That come over here. So the source IP will be 30.1.1.2 and 40.1.1.2. These are the FortiGate servers IP. Don't have nothing to do with that. I think it is not getting shown over here the ICMP traffic. But if we would have done a packet capture, we can see the source IP will be this one, destination IP will be this one only. Okay, there will be no visibility of this 10 dot and 20 dot because that packet is getting encapsulated within the GRE tunnel. What does GRE tunnel tells us? That source it's not showing over here. I'll just show you that. What the GRE tunnel tells us whenever you will send a traffic, this the source IP will be this one, destination IP will be this one. And within this packet, our actual LAN IP will be getting encapsulated. Okay. So also GRE tunnel supports multicasting, guys. That's why we can see the OSPF neighborship was up. Okay. And in this way we can we can if there is a side-to-side communication, we would have shared multiple routes. Okay, say for example, this is our data center, this is our remote site, and we want the communication. We cannot just basically give a static route over here for advertising the multiple routes. We can have control over the prefix sharing by using any kind of routing protocol. So that was my agenda. Like using the GRE tunnel, we can share the prefixes by running the routing protocol over there. So I'll keep posting such videos, guys, and thank you for all your support. I'll keep posting more videos on this topic of FortiGate. So stay tuned for the upcoming videos. Thank you.